this assessment, we're asked to show how an organolithium reagent might react with a ketone that has a hydroxyl group present. Now later on, we're going to learn that ketones are good electrophiles, but the key here is the presence of this hydroxyl group. We know that the alcohol has a pKa of 16, and we also know that organolithium reagents, oftentimes represented as if they're ionic bonds, so we could draw it as a negative charge on carbon and a positive charge on lithium. These are great nucleophiles, but also very strong bases. And so in the presence, even if our plan maybe as a chemist was for this to react with the ketone, the more likely thing to happen, what's going to collide first and be more favorable, is to just do a deprotonation. So this negative charge, the lone pair, can attack that proton, pushing these electrons onto oxygen. So even if we had intended to do a nucleophilic addition, a reaction we'll learn slightly later, what's going to happen instead is this deprotonation. And so the product we get from this reaction would be this alkoxide. One of the things we might think about is how can we avoid this potential side reaction? And spoiler alert, we could use a protecting group to prevent this deprotonation so that our intended nucleophilic addition to the ketone could happen. But that's for later on.